Hey, welcome everybody. I think I'm going to give, well, actually we have a lot to go through today, so we're going to go ahead and get started here as people continue to join in to the presentation. I don't know if we're able to turn those beeps off or not, Andy, but I don't think I have that preference on my side.
I don't think I can. Jansen might be able to do it. I'd give it a minute.
Okay, I can give it a minute then.
Nicole, Andy, I'll be able to turn that off.
I don't know if I heard you well enough, Jansen, sorry.
I was able to turn off the entry tone. Thanks.
Oh, wonderful. Okay. Well, that's great. So I guess I'll just welcome everybody here today. We're excited to have you. This is our 7th webinar in the series. And I am Nicole Burman, and I work for the Kansas City District Office. Today I'll be helping out Andy as the MC, and we ask that you add any comments or questions to the chat, and we'll try our best to address those throughout the presentation. As I stated before, we have a lot of great information to go through, so we'll continue to work through it as best as we can. And we are always here to help support all of our team members here. If there needs to be any follow-up or further discussion, we can do that too. So today, I will go ahead and introduce our speaker, Andy Temeyer. He is a registered architect and a program/project manager with the U.S. Army Corps of Engineers at the Omaha District. He has been with the Omaha District for 12 years. Andy has extensive experience in sustainable design and development at all phases of the project delivery, and has been on the teaching cadre for the Prospect course 244 since 2015. He is a graduate of Iowa State University with a professional degree in architecture and is a lead AP BD+C. He was born, raised, and currently resides in Council Bluffs, Iowa, and is currently serving as the Army Corps of Engineers Program Manager for the V-21 bed down at Ellsworth Air Force Base. So I'll go ahead and turn it over to you, Andy.
Thanks, Nicole. Like Nicole said, today we have quite a bit of content to talk through. You know, we pull some of this content from our Prospect course, and typically this is about a 3+ hours worth of content that we're going to go through. So it may go a little bit fast, but I do want to try to make sure that we leave some time at the end for questions. So I guess once again, if you have questions during the middle of the presentation, by all means, put them in the chat box, and Nicole will try to interject them as appropriately as she can. So the objective today is to describe how high-performance sustainable design relates to, I'm going to say what we call maybe a typical design process, And and we're going to try to kind of wrap a bow around some of the topics that we've talked about during the programming phase and kind of describe how all of this relates to the total project delivery lifecycle. As far as resources go, there's quite a few. I even cut some out from what we sometimes present, but obviously there's UFC 12002, International Green Construction Code. There's plenty of lead resources online. As far as how we relate this to the typical Army project delivery process and things like that, AR 420-1. The Mercy site is still available and has some resources. I'm not entirely sure if all of those resources are current, but there's still a lot of content on that site. If you are looking to relate this to Air Force design and construction process, there's AFI 321023 and a variety of other AFIs that you can begin to look at. And then ultimately, there seems to, over the last couple of years, try to reconcile our design process and design vocabulary with maybe more industry-wide terminology. So you'll see a little bit of that in this presentation. So the Architect's Handbook of Professional Practice is where we're pulling some of the design phase terminology for this presentation. And once again, when we talk about that terminology, schematic design, which we're going to roughly state is up to 35% design. Design development is, 35 to 65% design, maybe in some more Army or USACE-based terminology, and then construction documentation would be from 65% to 100% design. We've talked, I believe we've talked about this curve, the time and effort curve a couple of times during this webinar series. Ultimately, this is trying to communicate that the earlier you make design decisions and initiate design process, the more effect you can have on a project for the least amount of proportional effort. So ultimately, what we're looking at here is this line number 4, the green line, is what we would prefer to see the design process look like. And what you're going to hear about today is trying to make early design decisions and design coordination happen as early as you can in the design process in order to minimize cost and time impacts later on. So obviously, I think as Nicole and I work through this, like we're fully aware of the project, unique project constraints that we also often find ourselves under in trying to deliver projects for the DoD and other stakeholders, but ultimately this is the preferred design process. And that differs a little bit from the more traditional curve where it's more of a long methodical approach to where your process is peaking arguably after you can realize the greatest proportional benefit versus effort. So here's the project timeline that we've talked about multiple times through the course. Ultimately, I think I just lost my second here. Ultimately, we're going to be talking mostly about design year and budget year efforts. So that's after your programming and parametric design is complete. You'll initiate concept or schematic design in your design year and then proceed through design development and construction documents through usually around the end of your budget year so that you can solicit and award your project within your program year. I don't know how familiar everyone is with the code directives defined by AR 420-1, but that's we're typically talking about code 2 and code 3. I guess I don't honestly know why they're kind of flip-flopped from the sequential process, but those are all defined once again in AR 420-1. So code 2 is proceed to 35% design or proceed with concept design, and code 3 is prepare parametric design. Here's kind of a side-by-side comparison. We've already kind of talked through the parametric design, and we've even talked a little bit about or parametric design, and we've already talked about concept design to a certain extent during the programming presentation a few weeks ago. Ultimately, the OSD policy that we'll do a little refresher on has really forced our projects to accelerate to 35% design in the total project execution timeline, so that our projects have a level of definition early, so that within the budgetary cycle, our stakeholders have the opportunity to change their 1391 scope and budget thresholds with a more robust design. So, under parametric design, you're more high level, trying to make sure that you have a more basic study of the project scoping requirements, and then concept design is building on those to approximately a 35% design effort. So, again, as a reminder for programming, you're ultimately identifying a project team, conducting research on project requirements, your location, maybe some basic study of your building form. You're starting to talk about sustainability features, but it's probably a little bit more broad strokes. You may be doing a little bit more of a deeper dive on new technologies and systems that you may think are appropriate for the project. You're looking at low impact development, shared resources that the project may be able to leverage in delivering a more integrated project. You're setting and prioritizing scope and budget goals, and ultimately developing a 1391 or a draft 1391 and a parametric cost estimate. Sustainability is still part of that conversation. There's all kinds, we're not going to go through all these, but ultimately there's all kinds of sustainable features that could be part of the discussion during these early phases of the project delivery process. Energy modeling is still part of the equation. You can start some preliminary energy models we talked about. They don't have to be the full-blown, compliance models that you'll see later on in design, but some quick modeling, some massings, a study of building form and shape, or different building systems in a more iterative process to help determine what the proper system selection is for your project. You can do things like daylight analysis or study of orientation and things like that on project site to help really hammer down how much, say, square footage you need in the 1391. And this is just a reminder that there's all kinds of tools out there to help you conceptually understand your project requirements and help you study those in order to make sure that you can deliver on those goals later. I think some of this was output from Ecotech. I'm not even sure that that's a software anymore. Maybe we need to update this slide. It's never too early to start your third-party certification checklist. The different services have different third-party certification requirements, but ultimately you can start getting a handle on what credits you think may or may not be applicable to the project. You can run some quick calculations, and I think we talked about during the programming discussion that sometimes you even can start running actual calculations on water savings and stuff like that. You really can start diving into this stuff early so that you're not surprised by constraints later.
Andy,
yep.
do you know what software for the daylighting was shown for modeling?
I believe that this.
That was our question that we have. I don't know if it was this page or the one before. Yeah. I
think this one was Ecotech. It's listed up here in the little green box. Once again, I'm not even sure that Ecotech is an active software. It was produced by Autodesk, but
looking at the previous page, actually.
Was it? I know this is from Ecotech as well, the daylight analysis. That I think that we've used different tools within our district. You can do simple, as long as you orient your model correctly. You can use SketchUp. Ecotech used to be a tool that we used. We haven't used that recently, so I apologize that I don't know whether it's a tool still available, but I don't think it is. We have done some more robust analysis in AGI, but I think, but that's certainly not our preferred. It's a little too complex for that level of the level of development that we're typically at this stage. It's also, you should be completing your sustainability record cards. So there's different record cards for the different services. I believe this is the Army one, and this one can be found on the whole building design guide, but you can make sure you're using the correct one. But I think most services are tracking some sort of compliance tracker like this. And, you know, ultimately, these are supposed to be completed at each design phase. I'm not aware of any that aren't. And it helps make sure you have a good pulse on sustainability mandates and metrics and requirements throughout the project lifecycle. All of that is done in service of making sure that when you kick off your schematic design phase, that you're as well positioned as you possibly can. I know with these current OSD requirements, it certainly feels like there's a huge rush to get to 35% design right now. And I think I'd argue that that's to the benefit of the project and the PDT, but ultimately having a robust and complete PDR or PTR document and programming documents associated with that it really helps make sure that the project starts off on the right foot. So, you know, kicking off the design, schematic design phase, you know, it's extremely important that you identify a project delivery team to the greatest degree that you can. Make sure you have a handle on your programming constraints via some sort of draft DD 1391. I see in our presentation we kind of switch between a draft and an approved. I think ultimately that part of that's just confusion with these new OSD requirements, which we'll dive into here. You should have an idea of the owner's project requirements defined by the PDR or PCR, and then you should either have some indication of a basis of design, or you'll be defining your basis of design through that schematic design phase. You can hopefully start getting an idea of specifically which third-party certification credits or metrics that you're going to be tracking, and you can start. It's absolutely critical that you make sure that you're kicking off the design process in an integrative manner. That's required by it's required by the USC to use an integrative process, as well as it's a metric that's tracked on most third-party certification compliance tools. So as far as identifying your project delivery team, you know, ultimately this is a lot of times either managed by the design team lead or the project manager, the two working together. You know, develop PDT directory and make sure that the PDT all understands who plays what role. Helps identify, you know, create a sense of responsibility and ownership in the project. Hopefully it gives the team a broader picture of all of the individuals that support a project. You know, it's not uncommon to have, you know, if you develop one of these on a fairly straightforward project, you have 50, 60 people supporting a project in one manner or another. And then make sure that roles and responsibilities and lines of communications are clear. And then this is another topic that we will kind of cycle back on, but it's obviously, we're all aware of the complexities and the timelines associated with the design process, but it's usually as helpful as you can to keep your PDT as consistent as you can, from programming all the way through, you know, construction contract award and beyond. The less turnover, the less potential for lost knowledge or, you know, inability to reach out and understand maybe the guiding logic for why certain decisions were made. You know, as far as individual, or it's not that everybody has their key role to play, but you know, ultimately a project manager should be briefed by the design team on, you know, sustainability goals and requirements. Make sure that they understand that sustainability isn't an option to a project delivery process anymore. It is a requirement. It's part of the DoD building code, and make sure that they have enough understanding of those goals and requirements that they can manage expectations against the broader stakeholder group. Make sure your design team lead can serve as that conduit between the is well versed enough in sustainability requirements so that they can serve as a conduit between your project management hierarchy and your stakeholder hierarchy and the rest of the design team, and then use them as a conduit to resolve issues and conflicts on an interdisciplinary basis. A lot of times there's coordination type items that can be resolved within an individual discipline, but sometimes it's the design team lead that needs to come in and prioritize, maybe which priorities prevail when, say, a structural priority conflicts with an architectural priority or a mechanical and electrical priority or whatever the case may be. I think it's really important that your design, supervisory structure, sometimes it's easy for managers and supervisors to kind of lose track of the kind of ever-evolving policies and requirements and things like that associated with sustainability. So make sure that that there's an awareness that continuing education is going to be necessary to keep pace with all of that stuff, both within the staff and the supervisory structure themselves. I think I'll speak for Omaha District. I think it's been a bit of a struggle sometimes to include robust QC procedures on specific sustainable deliverables. So I think that that's something that we're continually trying to improve upon. But things like QCing lead forms and things like that, they kind of happen off on the side, and ultimately those are really critical to making sure that your project succeeds on a sustainability front. So again, I'm not sure that I have all of the answers to all of that stuff, but I think that that's something that there needs to be awareness of. And then kind of making sure that there's an awareness that when we talk high performance sustainable design, it may require more specific skills, and it may require a little bit more effort during design phase and some additional time, or it may need to be staffed more appropriately, or things like that. And then as well as design budgeting as well. It is the whole idea of this process is that we're spending a little bit more time in design, a little bit more design funding to realize a more high performing solution that will operate more efficiently in its end state or in operations. So as far as schematic design goes, I'm sure that there are various, there's Army standards for what constitutes schematic design, but ultimately the Lord Memorandum that we talked about a few weeks ago has really started to unify what a 35% design or a schematic design needs to be in order to meet OSD's budgeting requirements. So I'm not really going to do a deep dive on this, but the whole idea is you develop your design to this industry standard level, which is, in our terminology, a 35% design, develop a cost estimate at a commensurate level, and then conduct a design and construction agent certification. And the whole power of this is that it allows our stakeholders, if they so choose, to adjust their budget within the typical budgeting life cycle for a project. Again, during schematic design, it's not super centric to the DCA process, but research products and equipment, meet with product representatives. This is probably focused on, obviously every project is not completely unique on its own right. Projects are often the result of, some variation of the last project that the PDT executed. And so you're building on experience that you have collected over time. So ultimately, there should be some focus on doing a deep dive and investigation on systems that you're not familiar with, and then delivering delivering on that in a manner that allows you to manifest those in a design in design detailing throughout the project lifecycle, to prevent the possibility that you're going to lose sight of that somewhere along that timeline, and then end up with missed expectations or inability to integrate that within the project constraints. And then begin to develop a more robust understanding of how different systems are going to integrate with one another, and continue to perpetuate that trade-off process of, how may something like how may wall color affect my lighting design, or how may my my exterior wall selection impact or limit or promote mechanical and electrical design decisions, and make sure that there's always some natural tension there, but focus on balancing those priorities in a more unified and integrated solution. So ultimately, things like, this is just an example, solar tubes. Solar tubes, I'll speak for our district. It's a sustainability feature that we've used a lot, and we seem to favor, because they provide a huge amount of daylight with minimal cost input, and they're fairly easy to integrate into a design. However, they do affect things like your artificial lighting design and things like that. So and they may impact certain structural design decisions or finish selection, things like that. So make sure that those preferences are identified early, and that the entire PDT knows that those are being tracked, so that you can coordinate those throughout the project lifecycle. Begin your lead credit documentation. There's all kinds of documentation that can happen early, and so I think we've talked about some of this stuff before, but ultimately, define your FTE count and analysis. We sometimes do this as a memo, so that the PDT can pull it up, include it in the design analysis. This is not your code-based occupant analysis. This is more of a sustainability-oriented. How many people are going to be in the building? How many transients may you have? What's your building operation schedule? Things like that. Because those will impact mechanical design, or may impact your electrical design, as well as the architecture of the building. And so you can also begin, and sometimes even finish, your water calculations, get a grasp on things like sustainable site credits, and a variety of other things. Storage and collection of recyclables may vary a little bit depending on what third-party certification tool you're using, and what the installation level process is for storage and collection and disposal, or collection and, I'm losing the word, disposal of recyclables. Yeah. So schematic design deliverables, ultimately, your record card, you have some drawings, a design analysis that addresses all of your sustainability goals, and builds upon what you did in earlier phases, and then include all the sustainability analysis that you've completed to date, as well as LCCAs that back up system selections. Again, we're kind of starting to bridge between the design year and budget year, and that transitions us into design development. And so in trying to tie a bow around what the goal is for design development, you're trying to identify, coordinate, and make all design decisions that affect other design disciplines. And so that's in service of making your construction documentation phase that follows this as simple and as risk adverse as possible, as far as design changes and things like that. So this will occur after stakeholder approval of schematic design and prior to development of your construction documents. The MilCon code directives that you'd probably see attached to this are Code 6, Code 7, or Code T. Those are defined on the screen here. And again, those are defined in your AR 420-1. Again, the goal here is to keep your design development. You can start to see here I don't know if you guys can see my cursor. It looks like you can. Design development is starting to represent, you've already completed a huge amount of effort in schematic design, and then you're just continuing coordination in your design development. And this curve is already starting to trend, the idea is it's starting to trend downward. So your level of effort is attempting to keep progress with that time and impact curve. Again, I just talked about this a couple minutes ago. I think there needs to be a pretty robust understanding that the whole idea here with high performance design is that you are spending a little bit more money for a longer term payback, whether that's on the design or construction side. There's a huge burden on the PDT to do this, and I know there's a lot of contention about, well, does that mean we can increase our design budgets? Or maybe the statement is we're not getting more design money to deliver these projects. And we'll talk about that a little bit more, but ultimately, I think the push there is we've got to figure out creative ways and prioritize our level of effort in order to deliver on these expectations. With high performance sustainable design, a lot of our processes come out of, again, iterating on the last way we did things. So a lot of times our standards are developed out of how we did things, in the hand drafting days. Then they were modified for CAD, and then they were modified for BIM, or BIM design delivery. Ultimately, that's all rational and good, but at some point there probably needs to be some consideration of, is there anything, those are some pretty profound transitions in the way we go about designing things, and are there certain things in our standards and processes that maybe we should rethink to assure that we are delivering in the most cost-effective and efficient way that we possibly can. And once again, collaboration and communication amongst the PDT is absolutely critical. As far as processes and making the most of the design development process, I know we talked in the prospect course about creating an environment where collaboration can happen. In Omaha, we have what we call a BIM pit. It was created a long time ago. It's basically a room with a bunch of docking stations and screens where we can go in and collaborate in our BIM models. All of our designers can get around and in the same room and coordinate things that otherwise would probably happen in a cubicle, and the lines of communication would be a little bit disconnected. I'm not saying that's the end-all be-all solution for integrated design and collaboration, but ultimately, think about ways that a PDT can do that. In the virtual world that we're all kind of working from home and things like that, those things may change a little bit, but I still think that there's ways that we can establish a more collaborative environment, and we need to find a way to do that. Make sure that you're using the correct design tools for the level of design and development that you're in. I know we've talked about this in BIM circles quite a bit, but we tend to automatically default to the end product that we would do our CDs in. So if you need to do a adjacency diagram, in planning or programming or even in schematic design, a lot of people would immediately open Revit. Well, is that really the right tool to communicate what you're trying to communicate? Is it requiring more effort than the payback figure you get by doing it in that tool? Make sure that you're cognizant of not kind of burdening yourself with just the default solution. Maybe a PowerPoint slide is a better way to communicate some of that stuff, and maybe it would require a lot less time and effort on your part, and then you can catch up on the BIM stuff when you have a more resolved and clear idea of what you're modeling. And then try to resist to let established processes and norms drive a project in a certain direction if that's not what's best for the project. Spend a little bit of time talking about BIM here. Ultimately, building information modeling, or BIM, is something that's at this point not that new to the way that we deliver designs, but I'd argue that it's absolutely a critical tool for facilitating an integrated design process. BIM is not going to using BIM is not going to make your project more sustainable inherently, but it creates a collaborative environment or yields a collaborative environment where not only are you looking, at lines on paper and relying on your brain to manifest those lines in 3 dimensions, it creates a virtual reality representation of the building that you then can run, I think I'd argue, a lot more nuanced conflict resolution and integration against. So, there are all kinds of BIM tools and BIM systems and potential analyses that you can conduct with all of the data that you feed into a BIM model. But once again, it requires a little bit more input of data on the front side in order to provide a more integrated solution on the back. Touch on energy modeling here. Energy modeling, a lot of times it seems like energy modeling is something that maybe is owned by, say, the mechanical engineer, and it's something that's not clearly understood by the entire PDT, and it maybe is done once as a compliance model somewhere during the middle of the design process, and things like that. Ultimately, I really want to emphasize that energy modeling should be an iterative thing. It may not be, you may not be using the same tool the entire time, but find a way to use energy modeling, whether it's conceptual energy modeling or compliance modeling or something in between, to drive design decisions. And ultimately, during design development, you should be finalizing your concept models and helping you to resolve, complex coordination type interdisciplinary decisions and beginning your compliance models. But do what you can. I know there's some software type limitations with energy models, but make sure that the entire PDT has some sort of access to the energy model and outputs to make sure that the correct inputs are being put into those systems. So as you go about producing design development deliverables, I think it's really important. Again, there's all kinds of standards out there about what we need to produce for deliverables in a say a 65% design. But maybe think about what's with the focus on really front loading all of this data input and analysis into a 65% design effort. I think it can be stressful as a design member to feel like you also have to produce deliverables that are maybe what a 65% CAD drafted solution may be. So ultimately, I think what we find is a BIM model has a lot of data, a lot of information in it, but if you also have to if you have to feed that model with this vast quantity of information and modeling and things like that, it's also difficult to extract that information in the form of drawings and schedules and stuff like that on sheets in a time frame that a lot of times is expected of us. So think of ways that you potentially could provide a stakeholder with the information that they need, but are there different formats by which that could be done? Could that be a virtual BIM model walkthrough? Could you work through the schedules in BIM rather than focusing on outputting them onto sheets? Is there, is there a better way to deliver that information to assure that you're going on the right direction, but also not really creating a bunch of work that's not commensurate with the level of input that you've provided, or that you've already invested in the design. Ultimately, you're looking to deliver in design development a cartoon construction document set that include drawings and specifications, get an idea of all the drawings that you're going to need to provide to clearly communicate the design, and then a pretty complete design analysis that includes project and feature selection for the entire design, lead or third-party certification checklists, another version of your record card, and a robust sustainability analysis that includes all of the analysis and inputs that you've provided or applied to the project to date. So again, as you go through design development, your main goal here is to make all of those interdisciplinary design decisions so that as you move into construction documents, the burden for conflict resolution is as minimal as you can possibly get away with. Ultimately, you're still going to have to coordinate things during CDs, but ultimately your goal should be to minimize that burden. And the reason for that is that the more interdisciplinary coordination you're going to have to do during construction documentation, the greater the risk that you may find a fatal flaw or something in a product selection or system selection that may translate to you having a difficult time, following through on those goals and decisions that you made earlier on in the design process. Okay, so construction documentation phase. Sometimes it feels like this is the entire phase, I guess. Sometimes it feels like we start off 35% design, just focusing on producing construction documents. Ultimately, I think we're trying to create a distinction here that construction documentation is extremely important, but it is not the only thing that you should be focused on as you deliver high performance integrated design. So construction documentation phase is compile contract documents with adequate detail and clarity so that you can execute a contractually enforceable construction contract. This occurs after design development, not during design development, not before design development, but after design development, and then prior to advertisement and contract award. It's beneficial typically to the entire PDT to keep as much continuity between your teams as you move all the way from programming to schematic design, design development, and construction documents. There's obviously some change that's going to happen, but typically the best recipe for success is maintain that continuity.
Andy, we have a couple questions.
Yep.
There was a question before about a good daylighting analysis tool in Revit, if they have one that's working with lead daylighting credits. I cannot recall the one that we've recently got for NWK. Do you guys have one that works for both the analysis and for lead?
I don't know if I believe we've purchased an AGI plugin, but I can do some research on that and see if I can provide a response. I don't have an answer offhand. Ultimately, I'd say the natural tension in our district is who owns daylighting analysis? Is it the architect's problem or is it the electrical engineer's problem? And that debate kind of goes back and forth. But ultimately, I think it's a shared responsibility. And then the question is, what's the best tool to do it? I know we've done daylighting analysis in AGI, in standalone AGI. I know we've done some analysis in, like a long time ago, we would do it in, it was another Autodesk product. But it was very cumbersome and represented a lot of duplicative effort. I believe there are some lead plugins that will provide lead compliant output, but I don't know the titles offhand.
Yeah, or if they're approved. But yeah, because we also have some plugins too. I think we had a comment earlier about energy models, the add-ons to Revit that are really helpful. We have an additional question here asking about, and I don't know specifically which topic we were on here, but it says, how is this working when we have an outside AE firm developing the RFP? How about when we have an RFP more at the 10% design stage instead of the 35% design stage provided?
Yeah, so there's probably a lot of nuances to answering that question. I think what I would offer is I sometimes feel like, again, speaking from my experience and my experience only, we find ourselves a little bit behind the curve sometimes on programming, which then means that carries over into later design phases. I don't think that it's too early to ask. If you say you had, whether it's the district or whether it's an AE doing the programming on a project, it's not too early to start some life cycle cost analysis and things like that, so that when you move into RFP development, you can build on that stuff. I'm not sure that I understand the second part of the question. How about when we have the RFP more at the 10% design stage instead of 35% design or provided in the RFP? I guess ultimately you can put this burden, either on the AE to complete some of this analysis, or you can put it, I think there's instances where we put it on the contractor, the design, say if it's a design build contractor, on the contractor to complete that during their design process. And perhaps if you're at less than a 35% design stage, that may be what you need to do. But I would say that that's all stuff that really needs to be well thought out and discussed during RFP development, so that after award, you're not, kind of stuck trying to figure some of that stuff out.
Yeah,
Nicole, do you have anything else to offer that?
Yeah, I would second that. I think the detail of the requirements being in the RFP is very critical of what requirements they're being called back to and our standards to uphold. I have seen, the goal for me is when a contract's going out, we want to see it have the true requirements of what our contractor's going to be doing, even if it's, design build, even more so, right? Because we've got to be specific. And so with that, we want to identify what the expectation is. So a lot of times we'll, even with third party, be identifying that which ones are the typical ones we achieve, so that we make it more that next step in sustainability where we have to have that discussion coming back if they're not seeing either the life cycle cost coming through or the design elements coming through. There is that contract requirement to meet those specific potentially credits or guidelines that's needed, and then we can talk if we need to trade that out for a different one and so forth. And yes, it does depend on the customer. Army and Air Force have very specific things that they're looking for in their policies, and the VA is a totally different animal. They've got their own document to really look through with that data there.
Right. Yeah, and I mean, ultimately, I'm not sure that we can speak to the entire breadth of, stakeholder groups that I'm sure that we all interface with. But I'm definitely familiar with some of the challenges that you're referring to. Ultimately, decisions about when an LCCA should be conducted with respect to, issuing an RFP. Those are sometimes tough decisions, and they're limited by the capability sets that are available to the PDT and things like that. So ultimately, I think the fact that you're talking about them is a really good step in the right direction. And then the challenge is figuring out how to write contract requirements around those.
I would also say that we typically ask our AEs writing RFPs to do life cycle cost analysis to justify that they're meeting the goal that we asked in their scope, right, is to meet the UFC. And so even if we know that will be done again, maybe at a bigger level, right, not just a verification level, but, the implementation level during design, we still ask that of the RFP, because we don't want to put an RFP with contract requirements out on the street, identifying something that can't happen, or, knowing that it or not knowing for sure that we're going to meet that UFC requirement.
Right. I agree.
And then we had a question about acquisition strategies too.
Okay.
But I guess for me, it says his acquisition strategy, ISB, MATOC, or sole source. affect these besides maybe cost? I think our scope of works identify what the requirement is. So I guess for me, short answer, before you speak, Andy, I feel like they're required to meet the sustainability requirements, and so we would hold them still to it regardless of that acquisition strength.
Right. Ultimately, your acquisition strategy needs, I mean, I don't think there's an acquisition strategy by which this stuff cannot be accomplished. I think it requires different levels of input and insight and planning in order to deliver on those expectations. But acquisition strategy is not going to get you an exemption for meeting any of these requirements. So ultimately, there's still a challenge there. I'm not saying it's not a challenge, but it's something that the PDT has to sort through. Yes, absolutely, acquisition strategy needs to be part of the conversation as far as how you're going to accomplish these requirements. All right, I think we're going to probably move forward just so that we can get through what we can. And ultimately, as far as deliverables for construction documents, we need to produce some drawings. Typically, that's going to be by some combination of building information modeling, civil information modeling, and or CAD. CAD seems to be not gone, but it's less prevalent these days. Specifications, you need to make sure that you have your sustainability specification. I think it's now labeled sustainability reporting and requirements or something to that manner, 01-3329. And that may need to be modified for your acquisition strategy. Again, I know Nicole and I were talking about how your acquisition strategy and how the submittal process may be improved if you make some modifications to that spec to assure that, for example, your sustainability, your contractor sustainability proponent is reviewing submittals before they show up on your desk for review, and whether you're a DOR or whether you're just reviewing it for RFP compliance or things like that. You need to address your sustainable documentation via sustainability e-notebook, whether, again, if that's just requirements that need to be transposed into a design build RFP, or if you're the DOR, or if you're doing quality assurance on an AE design. You need a design analysis and instructions to field personnel, which ultimately are often overlooked. I don't know what everybody's experience is with those, but those are, sometimes part of the design analysis, or sometimes a standalone document that provides some guidance on unique systems or unique challenges to the project that maybe were discussed during design that need to be on our field people's radar as they transfer into construction, transfer the project into construction.
And I would say with that too, in thinking, especially since we're talking about sustainability here, there's sometimes when design teams have worked really hard to coordinate something that's a key component to that sustainability goal, and those are really kind of that aha moment to add those to the field instructions to make sure that next follow-on team that's working this knows the amount of effort, the importance, how that's integrated both into the ability to construct a facility, but also into the ultimate goals that we have as a project.
Yep, absolutely. As you develop design drawings, ultimately think about how you can convey sustainable intent in the clearest way that you possibly can. So this is there's nothing sacred about these details, but these were trying to communicate not only the air barrier boundary via a conceptual section that shows the perimeters, but how individual details may be addressed all on the same sheet, so that rather being scattered across a drawing set, plan sections and details, all of it's right there for somebody that's, say, doing air barrier testing, can show that intent. And then it can also still be referenced through and reinforced throughout the remainder of your sections and details and things like that. These drawings were showing continuity of an air barrier. They're not very easy to read on this screen, but once again, just trying to show what your intent is and how things are terminated and integrate with one another. In this case, I think we were trying to show continuity of perimeter insulation as it translated up from the foundation wall into through a slab in the context of a SIPS panel wall system. So again, specifications. We have specification, our guide specs, and I'm kind of assuming you're using guide specs. Obviously, that's not the case with all stakeholders. I think VA uses their own specs. But again, make sure that your sustainable is intent throughout your specifications. The different UFGSs have been are obviously being maintained, but you know, every once in a while you have unique project constraints and things like that that you need to apply to a project, and you're going to need to maybe write some additional language in there. Make sure that sustainability requirements spec is in there. Attach your lead checklist. Attach your record card if the contractor needs to maintain it through construction, which is typically the case, and then include all those other appropriate specifications. So total building commissioning, construction waste management. There used to be a bio-based, bio-preferred products. I think that's incorporated into another spec at this point in time. But make sure all of those things are manifested there. Otherwise, you're going to end up with some missed expectations in construction.
So I will also add really fast to this idea of adding to it when you need to clarify something. You know, an example, and I don't know how many of you have experience with the campus sites for third party, but that is one in particular that we have plenty of lessons learned on, in making sure that specification really defines that relationship, more so when you have multiple contractors working on a campus project, and really making sure that language is clear and added to that specification. Absolutely.
As far as submittals go, make sure that it's clear within your contract what the processes are for including you know, applicable submittals in your sustainability e-notebook, and make sure that it's clear to the contractor that certain products and requirements need to be considered as part of this project sustainability goals. Hopefully a lot of your third-party documentation is already complete. Again, to be transparent, we have a tendency to like put this on the back burner until late in construction documentation. That's just a recipe for you know, not problems, but missing goals and things like that. So, and then do quality control on this stuff so that everybody's kind of delivering this stuff on it with a consistent level of quality across your district. Your design analysis is probably mostly complete, but update it to show any changes to design and coordination with other systems and subsystems. And then, you know, I don't know that it's a requirement, but think about how you communicate sustainability in your design analysis. Is it fully integrated throughout all designs? Do you have a standalone section? Do you have a summary summary document? It may depend on how your district goes about communicating those things in their templates and in their standard process. But I think there's a variety of ways to do that.
And ensure that all elements of the UFC are covered, so that the
yes.
people know the history of it and
yes.
how you're complying.
And Nicole, I think maybe, I don't want to speak for you, but I think it's probably the sentiment is it's the easiest to put it all in one spot in one way or another. Otherwise, things get missed. But there's obviously different ways.
Yeah, that's how we handle it. So, but yeah.
Again, instructions to field personnel. Nicole and I were talking about. There's kind of a debate on whether this can be a part of the DA or just a standalone document. I don't think we're here to tell anybody which way it has to be, but it's still an opportunity to communicate additional intent and critical systems that need to be followed through after construction contract award. And once again, CD phase should probably primarily be a drafting effort and a spec editing effort. Hopefully, a lot of your coordination is already complete. And again, that all wraps up so that if you do this within the stereotypical project delivery timeline, your solicitation and award can occur either you know, you can start that process late in your budget year and hopefully award early in your program year, or you're completing up your CDs early in your program year for, you know, a later FY award. Obviously, that's very dependent on your acquisition strategy and things like that. We're kind of running out of time, but ultimately we had some discussion about, you know, some triage. I don't want to, I don't know how to type of conversations. I guess ultimately what we're trying to reinforce here is, you know, you have all kinds of resources core-wide, and then ultimately think a little bit about how you can prioritize your efforts. Sustainability isn't the only priority on a project, but it's definitely one of them. And maybe spend some time to figure out how we can balance all of our project's expectations and prioritize and focus our efforts on the things that really need clear and consistent design communication. There's all kinds of resources, whether that's inter-district coordination, reach out to your sustainability leads within your district. You can also think about alternate procurement strategies and things like that. I don't really think we have that much time to dive into all of that, but at least make sure you're asking the question. It's probably better to ask the question and kind of come up empty than it is to not ask the question at all. I think Annette's trying to emphasize maybe a bullet on this last slide, but ultimately make sure, whether it's in your design analysis, in your specs, within your RFP, what the intent of what you're trying to accomplish through the design process. Somebody will be able to pick up on that. And ultimately, you know, if the execution isn't 100% what you want it to be, perhaps it's something you can build on and learn from for the next project. So again, this is one of those statements, why are we always focusing on LEED when the project's underfunded and poorly scheduled in the first place? Well, number one, it's because it's a building code requirement per the USACE. But ultimately, I think maybe the pivot is focus on high performance design, that this provides a return on the taxpayers' dollars investment in a federal facility. And it's for the betterment of operations and maintenance of the facility, yields durable, healthy, and economical facilities over the long term. That's ultimately what we're trying to accomplish. So today we kind of circle back on programming. We talked about how to investigate design intent through schematic design. We kind of touched on the OSD DCA process, and we kind of followed that all the way through design development and how we attempt to coordinate all of our interdisciplinary design features during design development in order to minimize coordination through construction documents phase, and then again reinforce those sustainability requirements and goals in your contract documents. So I see there's a question. Is there a contact list for sustainability POCs in different districts? I thought that Mercy site used to have one, but I don't know if it's current. Jansen, do you happen to know? Or
yeah, I'm
Nicole,
not sure if that's 100% up to date, but we could look into updating that.
Yeah, I don't think it's up to date. I just shot Eric a message in our group. So Jansen, if you want to follow up with that too, we could always send that out.
I know our POC just got replaced because our STD POC retired earlier this summer. So I think that's a really good piece of homework that we could take. So I think we're already over time. I really appreciate everybody's time and attention. Nicole, is there anything else you wanted to add before we wrap it up for today?
No, I think we've covered everything. So of course, everybody, if you have additional questions, you can dive on our NS Teams group and we can identify that and or reach out to any of us here that's on the presentation.
Absolutely.
And yes, the recording will be available on that same link that in the files for the MS Teams, or also posted onto that YouTube link above.
Alrighty, thanks everybody.